Hi everyone. In this video we'll be discussing O of solid principle, that is open close principle. The open close principle states that software entities such as classes, modules and functions should be open for extension but closed for modification. So what that means is that we should be able to add new functionality without modifying existing code. The reason this is important is because suppose we had to create new service, and we for creating that new service we wrote some classes, we tested, or we wrote some functions, and we tested the working of the classes and functions through a lot of tests, and we found that whatever code we have written is working fine, it is bug free. We have put that into production. Okay. And a lot of people, 1,000 people, millions of people and billions of people are using that code, and it is working all fine. But tomorrow we decided that we are going to add a new functionality in that existing code, and now in order to add that new functionality, we have to modify the classes that we tested earlier. So after that modification, we cannot be sure that they will work as accurately as they were working before, and they are being used in the production code as well. So that is not a good thing, because after this change there may be bugs, there may be inaccuracies. So we will have to test everything thoroughly, and the existing code that is being used by people will be affected. So the OCP principle give us the idea how we should write our code, so that we can take care of this, like we don't have to modify existing implementation, existing classes. So to understand this, we'll be taking a look to two different examples. First example is shape area calculation. So in this example we calculate areas of shapes. So let's take a look to the code. There is one class rectangle. It has got constructor, and this constructor is taking width and height as the parameters, additional parameters, and those are getting assigned to self.width and self.height respectively. There is another class for a circle. It has got a constructor which takes radius, and it is getting assigned as well. And there is a class area calculator. In this area calculator we can see there is a method calculate area, and that is taking the shape object, and that shape object can be circle, rectangle, and it is checking whether that shape object is a rectangle or a circle, and on the basis of that it is returning what should be the area of the shape. So here it looks fine as at first, but let's see what is wrong with this existing code. So here are the problems with this approach. First of all, it is violating OCP. So the reason it is violating OCP, because right now there are two shapes, rectangle and circle. Tomorrow we want to add this area calculation functionality for triangle as well. So for that, what we need to do, we will first declare a class for triangle. That is fine, we are adding a new class, we are not messing up with the existing classes. But in order to make the area calculator calculate area for that triangle, or also we'll have to put another elif and check whether the shape is triangle, and then we will be writing the logic for calculating area for triangle also. So to make this achievable, what are we doing? We are modifying the area calculator class, we are modifying the calculate area method. So that is violation of OCP, because we are modifying the existing code. The area calculator was earlier tested and it was being used in production, but now we are modifying it. So this can break the existing code, and that's not a good practice. What else is happening? We are tightly coupling. What are we doing? This area calculator is now tightly dependent on every shape type. Every time a new shape is introduced, the area calculator need to have a elif thing, and it need to check against that type. So tomorrow triangle will be there, so after that their rectangle is also already there. So to, pentagon or some other shape will be there. Every time a new shape is introduced or deleted, it is being reflected in the area calculator code as well. So this area calculator class is tightly coupled with the number of shapes, and it is harder to maintain. The reason it is harder to maintain, because if we forgot to update calculate underscore area for a new shape, so this will not work. And if suppose we deleted if we modified some shape, again we need to do changes there. So every time there is some changes, it is going to take place in area calculator as well. And also this calculate area function can grow bigger. So suppose there are 1000 of shapes or 1000 of shapes tomorrow, so we need to put 1000 of elif in this. So that doesn't look good, right? Everything is, we have made this calculate area function method really large. That should not happen. So let's see how we can fix this. So this is the good example. So what are we doing? From ABC module, we are importing ABC and abstract method. So ABC, basically ABC is used to declare abstract classes. So that's equivalent as interfaces in Java. Okay. So we want to define a blueprint class, and we want the inheriting, extending classes to implement those abstract methods. Okay. So here what we have done, we are declaring the shape kind interface. Okay, that's abstract class actually in Python. So, and it has got a abstract method. So this abstract method is calculate area. It will be taking itself, and right now it is not implemented. So all the classes, inheriting classes, need to implement this, otherwise it won't work. So this rectangle thing is inheriting from the shape class, and it has introduced its own constructor that it will be taking width and height and assigning them to its self.width and self.height, and it is implementing this calculate area. And yeah, it's returning self.width into self.height as expected. Similarly for circle, we have added its constructor. It will be taking radius only and will be assigning that to self.radius, and self now it need to implement this calculate area class abstract method here, and it has implemented it. So this area calculator code is really simple. What it needs to do, it will just take the shape, and shape is of type shape. Okay, so since rectangle and circle are inheriting from shape, so those are eligible to be passed here, and it will just calling the shape.calculate area method. So the reason it is going to work, because shape, any shape, whether it is rectangle, circle, or any other shape, it will always have this calculate underscore area method, because without implementing this method, we can't instantiate any inheriting class. So that's why it is always going to be present. So we can see that it's a better implementation. Why is it a better implementation? Let's see. First of all, it is OCP compliant. So why is it OCP compliant? Because we can add new shapes without modifying area calculator. So tomorrow we need to add one triangle class. We can just declare a new class for triangle. It will be having its own init, base, and height, and it will implement the calculate underscore area method. And area calculator will work exactly fine with this also without any modification. So just pass the triangle as the shape, and we will call the calculate area method on triangle. So yeah, it is OCP compliant. It is more flexible. So every shape knows how to calculate its own area, make our code more modular, and it is easier to test. Every shape can be tested independently. So no matter how many shapes we are adding, every shapes can be tested independently without testing the area calculator again, because there are no modification in the code of area calculator. Let's take a look to another example to understand it more better. In this example, we are dealing with a discount system for an e-commerce site. So this is the bad example in Python. So here there is a class called discount, and it has got a function called, it has got a method. I'm calling it method because it belongs to a class. Functions are independent functions, independent methods kind of thing. So there is a method apply discount, and it is taking price and customer type, and on the basis of customer type, whether it is regular, whether it is VIP, whether it is super VIP, it is calculating the discount. So for regular, it is multiplying price with some other number, for VIP for other number, and similarly for super VIP. So this is how it is working. It is looking fine, but let's see what's issue with this. So problems in this approach. First of all, it's a clear violation of OCP. The reason for its violation is that, suppose we introduced a new customer type, platinum. So now we need to modify this apply discount method, and we need to add a elif, customer type equal to platinum. So it is modifying the existing discount class and existing apply discount method, and it can you know, obviously increase the risk of breaking existing logic, which was all earlier tested. And scalability issue. As customer type will grow, the method will become longer and harder to manage. So if there are, 100 or 200 customer types, then this apply discount method will be really long. Okay, so it's not practical, it's not a good thing to have these larger methods. It always indicate that something is going wrong, like something is wrong in your design principle, not functionality wise. But yeah, now let's see how we can fix this. Again, we'll be importing the abc. Abc means abstract base class from Python module abc and abstract method. Here we have declared this discount strategy abstract class, and it has got abstract method apply discount, and every inheriting class need to implement this apply discount. We have added 3 classes, so all these 3 classes are inheriting from discount strategy. First one is regular customer discount, another is VIP customer discount, and super VIP customer discount. Each of the classes have implemented this abstract method apply discount as per their logic. And in the discount class, what we have done, it is taking this discount strategy in its constructor. So we don't need to pass the customer type or discount type, whatever it was. In the apply discount method, we will be passing the discount strategy that we have declared in it, and it will be storing that as self.discount strategy. And this apply discount method will work as follows. Like, it will be taking the price, what is the price, and it will be calling the apply discount method of the discount strategy that it is stored in the beginning. So now this code is following the OCP principle. Let's see how it is following. First of all, if we decided that we now want to add one more discount strategy or one more type, discount type platinum. Okay, so in that case, what we'll do, we'll just declare a new class, platinum customer discount, and we can define how is it going to apply discount with the help of price. And this discount class doesn't need any change. It will just take the platinum customer discount here in it, and it will call the apply discount method of this exact discount strategy with the help of price. So it is working without modification in any of the existing classes. It is scalable and flexible. So now we can have 1000, 10,000, any number of discount strategies without making this discount class code longer, or there is no need to modify it whenever we are changing the number of discount strategy. We are removing, deleting, editing, anything. And the testing is easier. Each discount strategy can be tested independently without depending on other classes, without even minding other classes. So this is how OCP principle work. And this OCP principle help us to build extensible, maintainable, and scalable application. And by ensuring that our classes are open for extension but closed for modification, we can add new features without risking breaking old code.